Welcome back, students. Today we discuss the operational amplifier circuit, how the operational amplifier is used to construct the integrator circuit and differentiator circuit, and also how the linear simultaneous equations are solved using the operational amplifier, and what are the inputs of the integrator and differentiator, how it modifies the input signals, what are its outputs. We can discuss in this class in detail. First we start with comparator. What is comparator? It is an electronic circuit consists of operational amplifier. It compares the two input voltages applied in the inputs. We know well that the operational amplifier consists of two inputs. One is inverting input, one is non-inverting input. This comparator compares the reference voltage. The reference voltage is the external voltage applied to the potential divider resistance, the R1 and R2. We are applying plus VCC here. Depends upon the value of these two resistors, the voltage is passing across this resistor R2 is calculated as V reference is equal to this voltage VCC into R2 divided by R2 plus R1. This reference voltage is applied to the inverting input of the operational amplifier, and the input voltage is applied to the input voltage E1 is applied at non-inverting input of the operational amplifier. The output appears only when the input voltage we applied is greater than the reference voltage. So the comparator compares the input voltage, this input voltage, to the reference voltage and switches the output if the output voltage is above the reference voltage. If the output voltage EO goes more positive than the reference voltage set by the voltage divider, the output voltage is positive only if the input voltage is more positive. So it is set by the voltage divider. The voltage divider is made up of the resistor R1 and R2. If E input is greater than the reference voltage, the output changes its states. Otherwise, it remains idle. When the input voltage drops below the given reference voltage, that is, E input is less than V reference, the output switches back. By using this positive feedback, the basic comparator circuit can be easily converted into symmetric gear to reduce the oscillation around the switching wire. But in our syllabus, we are not going to discuss the symmetric gear. So we just know about what is comparator. Comparator is an electronic circuit which compares the reference voltage and the given input voltage. It shows the output voltage positive when the input voltage is greater than reference voltage. This enough. Next, the differentiator circuit. The operational amplifier is used to construct a differentiator circuit. In the differentiator circuit, we see the input resistor. The input resistor is replaced by the capacitor. the capacitor is connected to inverting input of the operational amplifier, and a feedback resistor is connected between the output and the inverting input of the circuit, and the non-inverting input is grounded. The input voltage is given here and the output voltage is taken here. It uses a capacitor in series with the input voltage. This produces the output voltage, the amplitude that is proportional to rate of change of applied input voltage. See here, suppose we apply a square wave. It gives the output as a spikes. Yeah. If you give a sine wave, we will get a cosine wave. So it transforms the waveform from a square wave to spike and sine wave to cosine wave. Now we discuss the circuit. The input resistor R1 is replaced by the capacitor in this circuit. The inverting, it is nothing but a inverting amplifier. The Vi is given at the input voltage. So we get the output voltage V out is equal to minus Ri. The output voltage V output is equal to minus R feedback into input minus Rf into current I. Where the I is the current, we know the current is equal to dq by dt. Q is the charge. Now the charge in the capacitor C, Q is given as C into Vi, the input voltage Vi. From this, we know that the V output is equal to minus R feedback into current I. So substitute the value of current. I is nothing but dq by dt, and substituting the value of Q is equal to CVI. So we get this equation. On solving this, we get dVi by minus RFC into dVi by dt. So the output voltage is directly proportional to differentiation of input voltage. So this circuit, this op-amp circuit differentiates the any input voltage applied in its input. So when we apply the square wave, it differentiates the square wave and gives the spikes as its output. For the sine wave input, the output of the differentiator is also a sine wave, that is a cosine wave, which is the out of phase, out of 180-degree phase. So it is also called as cosine wave. Now we go to the next circuit, integrator, operational amplifier as a integrator. So the op-amp is also used to construct a integrator circuit. This integrator circuit integrates the input voltage and give the output in the integration form. It generates the output which is proportional to the input voltage with time. So its output voltage is determined with the given primary output voltage at any time. The feedback, already we have seen, a feedback is given using a feedback resistor, but here the feedback resistor is replaced by the capacitor C, and the input resistor Ri is given and connected to the inverting input of the operational amplifier, The non-inverting input of the operational amplifier is grounded. The input voltage is given through the input resistor Ri. The I is the current passing through the input resistor. V out is the output voltage taken at the 6th pin. See here, this integrator converts the square wave into triangular wave. Here, triangular wave. And the sine wave is converted into cosine wave. So it integrates the square wave and sine wave and give the output as an integration form. So here the charge in the capacitor Q is equal to minus V output C, because the capacitor is connected at the feedback part. So the V output voltage is charged here. So the Q is equal to minus C V out. So the output voltage is equal to minus Q by C. We know well that the current is equal to dQ by dt. So the cross multiplication. So dQ is equal to I into dt. Taking integration on both sides. On integrating integral dq, we know we will get q. And now the substitute the value of 2 in the equation 1. So we get V output is equal to minus integration of I into dt by C. So on simplification, add the resistor here R and here also. So we get RC. I into R is nothing but a voltage. So resistance, the product of resistance and current is taken as a voltage. So now the output of the integrator is minus RC integral V input into dt. So the output is nothing but the integration form of the input voltage we applied. Here we are applying square wave and sine wave. For the input square wave, we get a triangular output in the integrator circuit. It integrates the square wave and gives the triangular wave here. And for the given sine wave, it shifts the phase, so it gives a cosine wave. Next we see the applications. These applications of the circuit includes is mainly used in the analog computers. So its output is proportional to integral of input voltage with time. This circuit is used to solve the analog differential equations. So next we see simultaneous equations. Solving simultaneous equations. The operational amplifiers used to solve any simultaneous equation. They are used to construct a circuit which solves the simultaneous equation. It has some node voltages at the inputs and output. The operational amplifier circuit represents the variables in the simultaneous equation. The outputs of the circuit gives the final solution for this simultaneous equation. The final solution is nothing but a voltage. It is in a voltage form. For example, we can solve the following simultaneous equation. There are two equations. The first equation is x plus y equal to 4. The second equation is 2x plus y equal to 5. From the first equation, x plus y equal to 4. From this equation, we are taking y. Y is equal to 4 minus x. The y is nothing but the output of one of the summing amplifier. Y is nothing but the output of the summing amplifier. From the equation 2, 2x plus y equal to 5, we are taking x. Here x is the output of any one of the summing amplifier. So we got two equations here. Y equal to 4 minus x equal to 5 by 2 minus y by 2. We know that the summing amplifier is the basic operational amplifier circuit which adds the number of input signals and gives in the output. From the first equation, we construct two op-amp summing amplifier with two inputs. In the first amplifier A1, the output of is equal to Y. Already I told you. And the input voltages are minus 4 and X. See here. It is the first summing amplifier. It is the feedback resistor. The two resistors are input resistors. The first summing amplifier output is Y and input voltages are minus 4 and X. So the minus 4 and X is applied here. So it gives the output Y is equal to 4 minus X. The Y is the output of first amplifier, first summing amplifier. In the same way, for the second equation, the second summing amplifier is constructed and its output is equal to X and the input voltage given to second summing amplifier is plus Y and minus 5. Here the feedback resistor is taken as R and input resistance is taken as 2R. Due to this 2 times of the resistance, we got Y by 2 and 5 by 2. So the input voltages are Y and minus 5 voltages applied here. This second summing amplifier gives the output X is equal to 5 by 2 minus Y by 2 depends upon the ratio of the feedback resistor and the input resistor. Now, the output of the first summing amplifier Y is here. This one is connected to one of the input of the second amplifier. So here Y. This Y is connected to here. Now the output of the second summing amplifier X is connected to one of the input of the first amplifier. It is shown here. See here. The output of the first amplifier Y is connected to one of the input of second summing amplifier A2. So the Y is connected here. The same way, the output of the second summing amplifier X is connected to first summing amplifier input. Due to this cumulative action, finally the solution, the value of Y, the value of X is measured here. The value of Y is not in the voltage form. The value of X also in this voltage form. So we can measure the solution of the simultaneous equation in the voltage form at the output of the first summing amplifier A1 and the output of the second summing amplifier A2. Okay. Today we have discussed what is comparator, what is differentiator, what is integrator, how a differentiator and integrator were used to differentiate and integrate the input square wave and input sine wave forms, how the waveforms are modified in the output, and how the operational amplifier is used to solve the simultaneous equations. Okay, write this question and answer, submit it to me. Thank you.